Hey everybody, it's Sherry Dutter from Tier 1 Interventions. Today, John Lee is going to uncover some new material. She didn't even tell me what this time. So, take it away, John Lee, and let's get started.
Mission accomplished. Mission accomplished. We are going to unpack exactly what that means in our first segment here of our live session today. That's what I'm using my assessment for, my midterm. And then I design my next few seasons to dig to mastery. So we get much more depth, which is going to ensure that my kids that have already mastered get the deeper versions of it, and my kids that haven't mastered get the mastery of the minimum. So in the next part of the year, this is how it's structured. Season 3 is one of my favorites, and I already have it planned. Season 3 is my absolute favorite, even more favorite than season 1 first 15 days. Guys, this is the answer. I can't wait because after my midterm next week, we have our 2-week winter break, and then we come back and it's the beginning of January, and season 3 is all of January. And there is a special name for it, and it's called Math in a Month. And I have a season 3 created for every grade level, Math in a Month. So January, so what do we have left? I want to do this proportionally. January, February, March, April, May. Okay, there's 5 months. Good, we're in fifths again. Oh, this is working out nicely. I didn't even plan it this way. I'm so smart, you guys. Okay, so I'm going to do fifths again. So I'm going to share the middle. Now, when I share the middle this time, over here, I realized I needed to share the middle a little bit bigger. See, this is number sense. This is why we use this strategy to improve number sense. So I need to share the middle over here this time a little bit bigger than I shared it over here. But see, you learn by doing that over and over again. That's what interactions over time means. It means that's why we do all of the stuff here, and then we do most of the stuff again here, and then we do the same stuff here, and the same stuff here, and the same stuff here. That's why we do the same things over and over, because we develop more of a mastery each time we're exposed to it. And I just gave that model here with, oh, I did that, and I needed to share the middle a little bigger. So I'm going to do that here. And then that's one of the parts. This has to be 2 parts, and this has to be 2 parts. See how they're more equally spaced? You learn from experience. We don't give that to kids. Regular, typical, traditional textbooks do not build the complexity as you go. They go on to a new topic. They're so bad. But what I love about textbooks, because I have a textbook, we've adopted a textbook curriculum, and there's a lot of great things in it. And I pull from it all the time because I don't want to have to create, I'm teaching Algebra 1. I don't want to have to create like every single quadratic equation I give to kids. Like I don't have the mental capacity for that. That would exhaust me. I don't want to have to create all those problems. So that's one of the ways that I use my textbook, and it's a lifesaver. So if I know I need quadratics that are gonna have like, so if I'm planning my second semester now, so this is one of the things that I've used my textbook for. I need all of the quadratics that have no solution, no roots, meaning the parabola is not going to cross the x-axis. I want all of those equation examples. I ain't smart enough to create them, okay? But the textbook is. So then I go to my textbook and I pull all of those examples, and I want some of them in each of these first 3 fifths here. See, that's how I use my textbook. But I've defined essentials because some of my essentials, and this is essential for 2nd grade. I've taught this to my 2nd graders in my district too. And then I have really hounded this with Algebra 1, radicals and square roots. This is a major essential that needs to happen at every grade level. Radicals, square roots. They're the same thing. A radical is a square root is a radical. So I'm telling you one of the essentials that I have drilled with my Algebra 1 kids, which is radicals. Using radicals, simplifying radicals, actually is what I use most of all to improve number sense. With my high school kids that have never like gotten a good sense of number yet. The other thing that I use are diamond problems, but I talked about that on another episode. Radicals and square roots, the reason that these are so essential is because there are certain numbers in the radical that I can take out. Those are called perfect squares. There are certain perfect square numbers that I want kids to know by memory, just like single digit multiplication facts. There are also certain square numbers that are not perfect squares, but they are square numbers. Kids that don't have number sense are not able to view radicals and square roots in the same kids. They don't have the same experiences and exposures. So with that number sense lacking, they can't take radicals at the algebra 1 level as far as they potentially could have. But if I start square roots in 2nd grade, now I don't just teach a unit on square roots. So you all listening to this live know what I'm about to say. The way that I expose square roots in grade 2 is we do the pizza problem. A pizza company makes square pizzas. What are all of the possible numbers of unit pieces, 1 by 1 unit pieces that could be in a pizza that would be a square pizza that that company could sell? Oh, we could sell a pizza with 16 pieces. That's a 4 by 4. 16 is a perfect square. Guess what, kids? There's this thing in math. This is what I said to my 2nd graders. There's this thing in math. Don't tell your principal I'm teaching you this. I should not be teaching you this. 2nd graders love that. I can't do this with my high school kids. They're like, shut up. But 2nd graders eat this stuff up. I'll lean in and I'll be like, I'm going to show you something mathematically right now, but don't tell anybody I taught you this. And I don't even want you to remember this. But there's a thing in math called square root. It's a weird symbol. You want to see it? And they're like, yeah. Okay. I mean, you can't do that with high school kids. But with my 2nd graders, they're like, yeah, we won't tell anyone. And then I also have to say, now remember, there are secrets that people are asking you to keep that are dangerous. And that's not what I'm talking about here. This isn't, you know what I mean? You have to kind of put that into.
So why can't you do that with your high schoolers? Why can't you tell them there's a secret about math? Why make the novel model even more radical?
Well, and this is funny, Sherry, because actually, Sherry, in my math class, I do that. What I meant to say was, you don't get the same reaction from high school students that you do from 2nd graders. It's funny, Sherry, I do that with my kids. By this point in the year, it doesn't even faze them anymore. At first, they were like, oh my God. And now they're like, oh, that's Miss Z for you. So, Sherry, great point. Great point. You're awesome. That's funny. That's funny. So anyway, at the 2nd grade, I said, I'm going to show you. And I'm talking like, so I show them the square root symbol and I say, what do you think the square root of 16 is? And they're like, 8. I'm like, it's not. What else do you think? So we have this whole, tell me about, we're relating it to square pizzas. So then I show them, well, wait a minute. We had that square pizza that had 16 pieces. What stage number was that? What were the dimensions? And they're like, oh, it was stage 4. It's got dimensions 4 by 4. Because my 2nd graders know dimensions of rectangles and squares, and they know stage number and quick dot and growing patterns. And we've done that in the first 15 days. So now they're like, but wait a minute, the stage number is 4 and it's a 4 by 4. I'm like, then that's exactly what the square root of 16 is. The square root of 16 is 4. And what that means is, in our pizza problem, you have 16 pieces of pizza. What are the dimensions? What is the stage number? The square root says, root the square. Root means find the solution for the dimensions of a pizza that has 16 pieces. That's what a root means. A root means it's kind of like the root word in English language arts. English language arts. Okay, so the square root is, what is the root of the square? I have a square that has an area or array number of 16. The root is 4. The square root is 4. The radical 16, the simplified version of radical 16 is 4. And I tell kids that, 2nd grade, Then I'm like, let's try another one. You want to try another one? They're like, yeah. Okay. So then I'm like, square root of 100. 50! I'm like, perfect. Let's draw this pizza. Go. Then I'll give them graph paper, and some of them will start putting like 4 pieces of graph paper together because they're going to draw 50 by 50. And I let them. Do not steal their struggle. You need to let them use tape and glue and put all these pieces together. And then you'll have like 2 kids over there and they're going to be like, why are they taping on? I'm like, shh, just let them do it. Because then I'll be like, whisper to me why. And they'll be like, it's a 10 by 10. I can fit it on. I'm like, don't tell, don't tell, don't tell. See, you have to have those kids go through the whole process to make the learning memorable. Those kids in 4th grade, 5th grade, 6th grade, 7th grade, 8th grade, when we do square root of 100, they're going to be less likely to tell me that the square root of 100 is 50 after me letting them suffer through this process of trying to create a 50 by 50. Because with my high school kids this year, guess what my Algebra 1 kids said? More than half my class said square root of 100 is 50. So I did, with my Algebra 1 high school students this year, that same exercise that I do with 2nd graders. I was like, great, draw 50 by 50. Now, I had less kids in my Algebra 1 taping graph paper together, but I still had other kids, like on the down low, I'm like, and I would give my other kids other square roots to do while other kids were taping paper together and not even noticing that it's a 10 by 10. Like, I had to have my high schoolers go through this. But what I'm telling you is, with the novel model, it's best if 2nd grade goes through this. And then they go through it again in 3rd grade. And then they go through it again in 4th grade. Because even though some of the kids that did the taping together and doing the 50 by 50 in 2nd grade, even if you do it every year, in 5th grade, some of those same kids are going to insist that they have to tape the paper together. And you're going to let them, but they're actually not going to go as far because they're going to start to remember their previous experiences. This is what builds fact fluency. So then in grade 2, when they're taping this together, and I will actually have kids draw 50 by 50, and then I'll use it first. I'll be like, look, all right, so square root of 100. How many pieces of pizza should we have in this? They're like 100. I'm like, good. Let's count and make sure we have 100 total pieces. They start counting and they look at me and they're like, fudge. This has a lot more than 100. I'm like, yes, but I get so excited and I'm like, I'm going to use your model for other lessons I'm going to teach this year because we're going to be able to figure out what square root makes this 50 by 50. Okay, we're not going to do it today, but I'm going to keep this. And you all are brilliant and you have done all of the work for me for another lesson. Do you see how I'm facilitating this energy? But the point is, what I say in essential chunks, if we get real down to the nitty gritty, square roots radicals are absolutely essential for kids to be seeing as early as 1st and 2nd grade with pizza problem chunk. So, season 3. Remember, this is my favorite. I'm going to make season 3 in red as a heart because it's my favorite. So season 3 is 1/5 of semester 2. It is in the month of January. It's got a special name. It's called Math in a Month. And I already actually have had my January planned because I plan my first 15 days in my January simultaneously because I use my first 15 day slides to then create my January. And I've already done this for my Algebra 1 class, and I've done it in a way that my other Algebra 1 teachers at my school, they're first year teachers. I want them to have a successful January Math in a Month.
John Lee, I want to close out Tier 1 Interventions podcast. And that is, if you are listening to this podcast and you are thinking, how do I get involved? You want to head over to your show notes and click on the link. We are offering you to come to a session like this, where you get all 2.5 hours at one shot for $47. You can then join another session for another $47, or you can buy the whole year for $497. Plus, you have to buy if you're going to go buy the whole year, you're going to have to buy level 1 as well. But the coaching and these conversations that we're having are $497. That sounds to me like a really good deal to really think the way you're thinking about not just mathematics, but occupational therapy delivery, speech therapy delivery, special ed delivery, and how we're helping these kids rethink, re-regulate, relearn, and think about life as whole.
Bye. Love
Bye.
you all.